Okay, I wanted to do a couple of more examples so that we have plenty to look at as we do our assignments and move on in the curriculum. So let's do another one. So I have f of x equals 2x plus 5 and g of x equals x squared minus 4. We're going to go through and do all four operations. We're going to add these, subtract them, multiply, and divide them. So off we go. Let's add these together. 2x plus 5. And we're adding that to x squared minus 4. I don't see any like terms that go with the x squared, so I'm going to bring that down. I like to cross it out to keep track with what I'm doing. I don't see anything that goes with the 2x. There are no other like terms. 5 plus negative 4 is going to give me 1. So when I add these two functions together, we get x squared plus 2x plus 1. Again, like terms have to have the same variable and same exponent. Nothing goes with x squared, bring it down. Nothing goes with 2x, bring it down. But I do have two constant terms, and 5 minus 4 is 1. When I subtract, similar thought process, except for we are subtracting. Again, when you subtract, I encourage you to keep change. So keep the first function that they asked you to do, change the subtraction to addition, and change the sign. Excuse me, you should do math in a pencil, sorry. Negative x squared plus 4. So keep this function, change the subtraction to a plus sign, change this sign right here. So again, just writing in pen so we can see it a little darker, but you should do it in pencil. So write your answer in order. The negative x squared comes down. Nothing goes with it. Nothing goes with the 2x. And 5 plus 4 is 9. So we have two functions that we're doing, and we're going through and we're doing each operation for each function. Now, sometimes that you may not have to do all four operations. They may just ask you to do, just add them together or just multiply. So make sure you pay attention to what the question is asking. All right, let's multiply. So if I'm multiplying, I'm going to do 2x plus 5 times x squared minus 4. So two options that we have, we can do the distributive property. So this is option 1 if you like to do it like this. Or if you like to do box method. So option 1 is the distributive property. Or if you like to do box method, 2x plus 5 times x squared minus 4. Both ways are going to give us the exact same answer. So this way is the distributive property, and the way on the right-hand side is the box method. So I like to do box method, so I'm going to go through and multiply this. X squared times 2x is 2x to the third. X squared times 5 is 5x squared. Negative 4 times 2x is negative 8x. And negative 4 times 5 is negative 20. Combine like terms, put it in order. Cubic term goes first. Nothing. I have no like terms in this problem, so you just write it out in order. Biggest exponent to the smallest. And voila. So we just did the box method. Those of you that like to do distributive property, I assure you, you're going to get the exact same answer. 2x times x squared gives us the 2x to the third. 2x times negative 4 gives me negative 8x. 5 times x squared gives you 5x squared. 5 times negative 4 gives me negative 20. Combine like terms, you'll get the exact same answer. And last but not least, the f divided by g. So our f is 2x plus 5, and g is x squared minus 4. So f is going to go on top. That's 2x plus 5 divided by x squared minus 4. We need to take the denominator and set it equal to 0. So take x squared minus 4, set it equal to 0 so that we can figure out what our denominator cannot be, because that means if I graph it, there's going to be a hole or a gap there. So add 4 to both sides. Take the square root. X cannot be positive 2 or negative 2. So we took the denominator just like we did with the previous examples. We solved this equation. X cannot be positive 2 or negative 2. 2 times 2 is 4, and negative 2 times negative 2 is 4. So X cannot equal plus or minus 2. Let's go through one more example to make sure we've had lots of practice on adding and subtracting like terms, either doing box method or distributive property, and then dividing and finding what our denominator cannot be. So last one. So we're going to take the trinomial, which is our h function, and we're going to add it to the g function. Still going to go through and add or subtract like terms. Still going to go through and do that. So we're going to add the two functions together, and then right after that, we're going to subtract these two functions together. So if I rewrite it out, that's x to the third minus 2x squared plus 2x, and I'm going to add that to 2x minus 3. I don't have any cubic terms, so I'm just going to bring that down. I don't have any other square terms, so I just bring that down. I do have two linear terms that we need to add, so 2 plus 2 is going to give me 4x. And I only have one constant term, so that comes down on the end. Make sure you write your answers out from the biggest exponent to the smallest. So cubic came down, nothing matched with it, nothing matched with it. These were the only two like terms that we had. We added those together, and then the constant term came down. I'll do the same thing with the subtraction. As you know by now, I think it's a good idea for us to do keep, change, change so that we don't mess up on our signs. So change that to a plus and then change the sign of everything after. So the subtraction sign changed to a positive, that changed to the opposite, that changed to the opposite. So keep, change, change. Nothing goes with the x to the third. We're just going to bring that down. Nothing goes with the x squared. We just bring that down. 2x plus negative 2x, they're going to cancel each other out. Nothing goes there. And then I bring down the 3. So we have added these two functions together, and we've subtracted these two functions. Again, the key to adding and subtracting, like terms, like terms, like terms. All right, now let's multiply. So if I'm going to do a box, my box is just going to be bigger. So x to the third minus 2x squared plus 2x. So it's just making my box bigger. And then 2x minus 3. So I took the first one, which is x to the third minus 2x plus 2x, and I just recopy that on the top of my box. Same thing we did in the previous examples. And then 2x minus 3 goes on the side. So the first few boxes we did were a 2 by 2 box. This is a 2 by 3 box. If you want to do the distributive property, which is no problem, we're going to get the same answer. You would do x to the third times 2x minus 3, negative 2x squared times 2x minus 3, and and positive 2x times 2x minus 3. So we take all three of these and we multiply it by each of these so that you still get the 6 components that we're about to get down here. So we're going to go through and we're going to multiply. 2x times x to the third is 2x to the fourth. 2x times negative 2x squared is negative 4x to the third. 2x times 2x is 4x squared. Negative 3 times x to the third is negative 3x to the third. Negative 3 times negative 2x squared is positive 6x squared. And negative 3 times 2x is negative 6x. We go through and combine like terms from the biggest exponent to the smallest. X to the fourth is the biggest one that I see there. There are no other like terms that go with it, so bring it down. I see some cubic terms that go together. We add these together. Negative 4 plus negative 3 is negative 7x to the third. My quadratic terms go together. 6 plus 4 is 10x squared, and there's only one linear term. So our final answer when we multiply these two functions is 2x to the fourth minus 7x to the third plus 10x squared minus 6x. And last but not least, let's divide these. So again, we just take h, that's going to be our numerator, and we take g, and that's going to be our denominator. So h is x to the third minus 2x squared plus 2x. That's our numerator. And our denominator is 2x minus 3. Take our denominator, set it equal to 0 so we can figure out what our denominator cannot be, because you cannot divide by 0. So somewhere off to the side, you solve your equation. We need to add 3 and then divide by 2. Add 3, divide by 2. Add 3, divide by 2. So x cannot be equal to 3 halves. All right, so this has been operations on functions.